Hello, my name is Ahmed. I'm a senior student in electrical engineering, and my mentor is Dr. Kher. And this is my research project, the Smart Solar Blinds. The idea of solar panel is to absorb the sunlight energy and then convert it to electrical energy and store it in a battery. This stored energy is ready to use whenever you need it, or you can use it directly to the grid supply. For the solar panel to be fully functional, it's really important to have full exposure to the sunlight. So the solar panels need to be constantly in direct contact with the sunlight. But this can be difficult to obtain the sunlight absorption through the day because the earth is constantly rotate and changes the position of the sun. To fix this problem, I had to ensure the panels are constantly facing the sun and aligned with the direction of the sun. So the solar panel should estimate and constantly rotate in the direction of the sun to achieve the maximum effect. So the idea was born. The idea is to make a solar panel mounted in the blinds that can rotate with the sun direction. This project presents the design, mechanism of operation, application, and overall benefit with the limitation involved in the use of smart solar blinds. For the design, there is two types to design the solar panel, which is active and passive solar tracker. Active tracker depends on a sensors. Passive tracking depends on a gravitational system. Passive tracker doesn't use any motors, no gears, and no controller. It just uses the sun heat to move liquids inside the panel from side to side, making the gravity to turn the track rack and follow the sun. But in this project, I'm going to use active tracker because I think it's more efficient. It tracks the sun from east to west using electronic sensor and servo. So for example, if it's cloudy or raining, the sensor will look for the brightest side of the sky and move the panels towards it. For the mechanism of operation, the solar panel has tracking controllers that detects the position of the sunlight and then sends data to the processor, and the processor sends commands to the controller to control the blind's position. There's two types of solar tracker, feedback or open loop controllers. The feedback are sensors made of photosensitive elements. Since the photosensor control tracker are horizontal due to disorientation at dawn or low insolation, an auxiliary tracking system that control motor rotation is essentially. The open loop controller uses microprocessor but does not require any sensor in determining the sun position. Sun movement is predicted through an astronomical correlation programmed in the microprocessor, so that it can be anytime calculated the sun position. But the negative side of this controller that it could lead to errors in determining the sun position because of the clouds or low radiation. So in this project, I needed a fast microcontroller that operate in low voltage. So what I did is instead of getting Arduino, I made my own microcontroller that operate in 3.7 volts, which is less than what the Arduino operates, and it's perfect for my project. Microcontroller is used to control the rotation to ensure the alignment of the blinds with the direction of the sun. Figure 1 shows the electrical components of the system including Atmega 328, which is the chip that I use in my microcontroller. The two sensors in the flowchart shown in Figure 2 is to detect the sunlight and then sends the data out to the microcontroller to process the data and sends the proper commands to control the solar panel. In the next slide, I will show the actual implementation and the final design of this project. Two sensors were placed, one in here and one here. Microcontroller, server, charging station. Microcontroller receives the feedback from the sensor and sends command back to the servo to control the blinds in the right sunlight position. Charging station have two outputs. It can charge any device through a USB and it can recharge a lithium battery. The smart blinds is fully and completely autonomous. The microcontroller in here it powers by itself using the solar panel embedded on top of it. The charging station is on all the time and it charges the battery by itself and stops when it's full automatic. There is 5 circuits embedded in this project. All the solar panel is in series, 2 voltage booster up to 5 volts, an overcharge protection, and then microcontroller. In conclusion, the project was a success. The blinds constantly tracking the sun position and keep absorbing energy to use. This concept proves it's cheap and saves a lot of money and helps the ecosystem. For the future plans is to maximize the area of a solar panel to absorb energy and to study the stored energy over a day during each season. Also, improvement will be made during rainy season and cloudy conditions. In the next slide, I uploaded a short video. I hope you enjoy it. Thank you.